Alright, thought I'd do a video on what I've been working on lately, mainly this visualizer that I've called Orion because it looks like a constellation when it plots it out. If you follow me on Twitter, I'm not on here very much anymore, but I have been posting lately about this visualizer. And I haven't done a video yet on it, so I thought I would do a quick video here on YouTube to talk about the visualizer and, what is it, why, features, etc. So, what it is a relation transaction. Here, let me pull it up. Pull up an example. So, here's one. Let me pull up a new a new transaction. It'll always pull up a random one if you don't have anything filled in for the get. So here's something very simple, very basic transaction. You've got transaction ID plotted as the node. If you click on it, then you can mute the other nodes, see where funds go. Okay, this one to this address. There's that address. And then we have the initial input transaction, and that's where it ends. So very short, not a ton of data. So something that I've been adding is the ability to expand on these nodes. Because what it does is when we visualize this transaction, so you can think of your typical explorer. Here's an example. You've got your inputs on the left, where the money came from, and your outputs on the right, where the money goes. Just in simple terms, right? Where it comes from, where it goes. Well, the visualizer, so that would be your inputs, where it comes from, outputs, where it goes, the original transaction. But what also it does, it looks for the next transaction, like to see if it's been spent, if any of those outputs have been spent. And if so, it grabs all the inputs that are used, not just that one, but all the inputs used for the next transaction and the next outs. That way you can follow where funds have gone just by putting in a single transaction ID. Some of these can get fairly complex. You can see I've posted on my Twitter some of these that I've been looking at. Some can get really big, tangled webbed weaves and so on. So I've been working to try to just enhance and improve on this, and that's why I want to talk about it. It's a privacy tool. I think everyone needs to be aware of different input heuristics, which is characteristics of inputs or patterns of inputs or values that Chainalysis uses to make assumptions about who owns what coins. And I believe there has been a precedent in U.S. courts where Chainalysis has been used as, as a precedent saying, oh, this person owns that. So it's good to know your own transactions you're looking at. I did some P2P transactions, and I found out that some buyers were willing to pay premiums for KYC-free coins, and then when I traced where they sent their coins, they immediately withdrew to Binance, which raises this suspicion: why pay a premium for KYC coins if you're just going to move it straight to Binance? You're A, removing the KYC, immediately going to Binance, and B, you could have bought at Binance at spot, so why pay extra? More than likely, a Fed or something, or maybe the funds were dirty. I don't know. But that's something that you can use this tool to look at, is to see where did the funds come from, where are the funds going. What we have currently in the space is oxt.me, which is great. Great tool. Not trying to compete with it. Just think we should have another one. And it's something I just want to work on because I've done a lot of wallets, stuff like that. Why not something that doesn't incorporate wallets? Why not do a visualizer? So of course it's free open source software like most of the stuff I do. You can find it on my GitHub, coinables/Orion. The folder structure is very simple if you want to check it out. The first page is just a screenshot and the README. Source is source files. I am using something called sigma.js to do this charting, and then I expand on it from there. A lot of people use D3. Sigma is a bit different. You could look up about Sigma.js and why you might use Sigma over D3. They're similar products, but actually quite different in how they work. So plugins and source, that's all about Sigma. So you can ignore that unless you're going to go down deep and make changes to Sigma. In public, the library folder also contains Sigma file, or sorry, jQuery. my jQuery dependency, so I don't have to go to a CDN. And then I've got two files here, link.html. That's my newer file where we can expand. I'm going to show you that in just a second. So here's an example of original transaction on the left, and then when you expand it, it goes to the right. So that's under link.html and orion.html. This is the code itself. It's just CSS, the HTML, and then JavaScript. I'm using local storage for the expansions, using it as a memory bank. And you'll see here I have some known addresses, so that will pop up if you're scanning. So let's see if I can get one to come up. So where were we? We were here. I see my transaction ends at 49E. So if I want to expand this, I can type 49E in here, and I can copy it. So that way I can enter here and go here. But before I do that, I'm going to do a memory plus, similar to a calculator, which is going to save the current plots on my chart. Not in the exact spot, but it's going to save the data. So then when I go view to this next transaction down the line, it's going to load up those transactions as well, plus this old one. So you'll see. Hit view. So there it is. We can zoom out. On our left, you've got the blue nodes. Yeah, let me see if we can zoom out there. Our blue nodes, that's the original transaction. 49E was the new transaction, so the red stuff is the new data provided by when we searched in there. If I want to see where funds are going too, I can just kind of take a look up here, space and back, and I can see the different value amounts. Looks like 114 B1Q and K is where the bulk of the amount is going. So where is that? I can click on it. It could show me, okay, that's where funds went. I'm trying to look where funds came from. So which one is? Oh. That's BC1. That was a BC1. So I could do either down A4 or I can go down C1 to add to see where funds go. So let me see, BC1Q3. That one went 06. So that looks like the larger amount. So I'm going to go down this road. So that's C1A. So what I'm doing here is I'm getting the transaction ID by calling it out. And then I'm going to do another memory plus. So now I'm going to save the data that I had saved, this new data, and now I'm going to also pull data from this transaction C1A8 by putting it up here and hitting view. So now I can expand my visual again. I'm assuming it's going to be a large transaction since it's taken a while to load. It's probably going to be a ton of plots, which usually suggests that there's an exchange involved or multiple exchanges for the source funds. All right. So as you can see, a lot has changed here. On the left, we had that original transaction, right? Just those few plots. And then over on the right, it tried to plot it all. This has got to be close to 1,000. But I can see it already over here. Our big squirrel is, or circle, is Binance Hot Wallet. And it picked that out automatically. You know, so I didn't have to type in Binance. I didn't have to say go look for Binance. It just says, hey, look, here's the Binance wallet. So I know this random transaction that I pulled up, just 2 transactions away, is related to the Binance wallet. Now, so if we go here, it's under link HTML and Orion, so it's on both of them. Remember, Orion doesn't have the expansion feature yet. That's where I'm doing the memory plus. Now, if I wanted to delete what I have saved, I would just do a memory minus, and then my storage is cleared out, and then I can go and explore other transactions. Transactions don't have to necessarily be related. You could store one that's unrelated and pull up another one, and you have 2 side by side that aren't connected. If there's a line connecting from the left to the right, that's how you know that the transactions have a relation. Something else here, I could see another large one is 167. I can go search, find out some more information about this address, 167. I can see the amount was 3.4 BTC. If I'm having trouble finding it on the chart, I can click on it, get a big greenie. And then this is when I like to do stuff. I go to oxt.me, and see, do they know about this address? It says Anon. Okay, well, there's other sources too. There's one by Carnegie Mellon University that keeps track of basically everything related to BitMEX. If it's ever sent to BitMEX, it's a huge database. This has nothing. So no relations there, but always worth checking. And I also like just doing like a DuckDuckGo search too on an address. I could follow where this goes on Twitter. I don't necessarily feel like if I if this is someone's personal address, I don't want to necessarily call them out or pull up their Twitter on a video. But anyways, these files I'm hosting or I'm saving the known address data here in arrays. So I've got known address, I've got a whole bunch of arrays, and then the known check, which is also the mirrored arrays without the label after it. So that's how it knows in this visualization that this Binance hot wallet belongs to Binance, because it's actually one of these many listed addresses. There are a lot of popular addresses, and they go through, different phases. So these are the current popular addresses right now. So you'll see when I just pulled up this random transaction and then I followed the source funds just by 2 levels. Again, I didn't pick the transaction, it was totally random. I ended up at finding a match on the Binance hot wallet because it's a very popularly used wallet. So that's what I have built there. So I was showing you guys some of the code here. And if you're wanting to make edits and stuff to it, I would say, I'm doing a bunch of just AJAX calls to mempool space. So it needs to be hosted, otherwise you're likely going to get a CORS error. So if you don't have it, like right now I have mine up github.io. If you don't have a server where you can put in the CORS header request, you can just mount one on your own system using something like XAMPP. That's a local web server. But if you try to run this HTML all by itself without a server, sometimes the AJAX calls work, and sometimes you might get a CORS block request, which I find it odd that it's inconsistent, but whatever. So if you're ever having that issue about CORS requests, it's probably because you're just running the HTML file on your computer and not on a server, and it blocks the anonymous header for the CORS. Okay, so that was talking about how we just do the AJAX. This is where I start gathering all the different data that comes back from mempool space, and then I sort it using a duplicate check, because transactions are related, and sometimes that same transaction is going to come up, or that same address is going to come up. So I had to do duplicate checks so I wasn't plotting the same address or transaction over and over. And then, let's see, everything below, let's see, line 525 is about building the sigma chart. Initially, I just set up some arrays, and then I push some of those details over, including the amount, node ID, alias, and the channel colors. And so if you want to mess with the colors, you can check that out down here. I'm doing, so like here, there's a little bit of a heat map, right? You see some of them are colored just typical blue. There's nothing special about that one, but this light blue, that means there's more than one connection. So it's a lighter color, like a hotter star. And then the ones that have a ton of connections will be white instead of blue. So in the code, that says, hey, if there's more than 12 connections to this node, make it white. If there's more than 2, make it light blue. Otherwise, just make it its default color. So I see there's a white one sitting right here. So I know this was a popular transaction just because I can see that it's white. Now that all these other ones that are red, that's like the one that's blue on the left-hand side. It's fairly insignificant. It doesn't have a lot of connections to it. You may not need to explore it, but you also might. Also, the sizes of these matter. Most of these are the same size. So in the code, when I go down here, is I check how many Satoshis belongs to this output. If it's more than a whole Bitcoin, so if it's more than 100 million, make the node size 20 pixels, which is one like this, one like the Binance one. Otherwise, we'll make the node size 9 pixels. I found out that just that seems to be the size that works best. You might find a size that works better for you. Feel free to change it. This is free open source software. Do whatever you want with it. In here, I commented out a ternary comment or a ternary operator where I was trying to do like a scale for the sizes, so that, I was saying if it's greater than, 5 Bitcoins, then just make the size 5 pixels. Otherwise, make it, the size that it actually comes back. Now, I was also able to change that for other ones, but the scaling came out weird. It was hard to see the colors. So I just commented it out there so you could try that if you want to. And then also, this section is what I added for the x coordinate, and that's related to the link.html. This code does not exist in Orion.html since we're not doing any of the expansions or linking. So what we're doing is we're saying, we're checking to see, is this memory data or is this new data being loaded up after the fact? If it's old data, the initial data, it comes out on the left and the default node color is blue. If it's new data, expanded data, then I come up with a random x coordinate on the right hand side, right? So that's fairly simple there. You can change that how you want to. You could change this to maybe like the y coordinate, and then you would update down here instead of having a random y coordinate between 0 and 10. You would say, hey, I want this y coordinate and update it here. Change your x coordinate, however you want to do it. Some other options here about with Sigma. From 635 down is default Sigma code that I just took from one of their examples. So I think it's that much. It's just a few lines there. That's just the default thing to create a simple chart. So that's not my doing. That was default. And then basically the rest is what I added. Again, I'm using local storage for memory. That's the m plus, m minus. So if I want to show getting rid of this, I would do m minus, memory cleared. Now I can load up, let's just load up another fresh random transaction. And now it looks like this. So kind of back where we started. We've basically gone full circle and we've looked through the code, the node search. So up here, this is based on when you type a key, it'll start to look for a match. So kind of like a hot instant search, however you want to look at it. I commented out this and basically saying, before I had it only show results if someone types something in and there's a match. But I also wanted to show everything if I were to backspace and leave it blank. So if you wanted this to go away, you can hit space to make that stuff go away, or you could uncomment out where I put if it's greater than 0. Because if you do that, then this part won't show up, if that makes sense. And that is everything that I got. That's all I really wanted to talk about, and I wanted to show you how you can explore the transaction. The other stuff that I'm working on, you can just head over to my GitHub and see. Again, the transaction visualizer, and then I push it to GitHub.io, my multi-sig coordinator, and I also did this SPV wallet recently, which is super experimental, but just sharing the idea. All right, that's going to wrap it up. See you guys next time.